see the next slide. So a carboxylic acid peak will usually be a broad peak, and we explain the reason, which is hydrogen bonding, starting from 2200 to 3600. This is the easiest thing you will be looking at, and you can easily identify it. Alcohols usually between 3200 and 3600, and then amines will appear between 3350 and 3500 peaks. So for example, this is the alcohol peak. Okay, as you can see here, this starts around 3200 and extends up to around 3600. So this is an alcohol. A carboxylic acid will look different. So it will be a broad peak starting almost from here up to here. Whenever you see this, in addition to this peak, which is, remember, this is a 1500, we have something here, carbonyl. So this is telling us that this is a carboxylic acid. This broad peak, in addition to this, will tell you that there is a carboxylic acid functional group. Whereas if you look at amines, remember, if you have a primary amine, then you will see those two short peaks in this region. Whereas if you have a secondary amine, then you will see this single peak. So there is no way to get confused between the OH, the carboxylic acid, the secondary primary amine, or the secondary amine, because their peaks look different, and they even look different than the ones which we discussed in the previous slide, which are the carbon hydrogen one, because usually those are shorter and they are very sharp peaks. The one which corresponds to a double bond, or the one which corresponds to a triple bond. Now, in the rest of this video, we will be solving some exercises just to apply what we learned before. So in this question here, and this is from the book, which is Organic Chemistry by David Klein. The question is, using this IR spectra, we have to say whether the compound is an alcohol, a carboxylic acid, or neither one of them. Again, looking at, let's say, starting with a 1500. If I draw a 1500, a line at this 1500 here, in this region, up to almost 1800, there is nothing, so there is no double bond. And then there is also no triple bonds in this region, so this compound doesn't have a single bond, or it doesn't have a double bond or a triple bond. The only thing which we have is this peak here. This definitely corresponds to an alcohol, not a carboxylic acid, because remember, in carboxylic acids, you should see a peak here, and also the peak should be broader. So this is definitely an alcohol. Let's look at this one now. Again, 1500, we have something in here. This is a short peak, so probably this is an alkene, but now we are not looking for alkenes, we are looking for carboxylic acids or alcohol. There is nothing here in this region, so that's why I cannot say that definitely this is not an alcohol or a carboxylic acid. This peak, this spectrum here, you can see this broad peak, which is between 2200 and 3600, so definitely this is a carboxylic acid. Again, in this spectrum here, we may have a peak here, so this could be an alkene, but usually there is nothing in here, so it's not clear, but definitely, again, no alcohol or no carboxylic acid, just to answer the question, this question right now. Those two definitely correspond to an alcohol because of this peak here, and to an acid because of this broad peak, which is between those. So in addition to this C double bond O group. Now let's take more examples, and now we have to be more specific. So we have to match all these spectra and say whether these are a ketone, alcohol, a carboxylic acid, or a primary amine, or a secondary amine. So let's look at these peaks, starting with the first one. Step one, drawing a line at 1500. And then looking in this region between 1500 and almost 1800. And I can see that there is a peak, and it is a peak which is a sharp peak with high intensity, which means that probably this is a compound which has a carbonyl group. Since there is nothing here in this region and all these compounds, the only one which has a double bond O group is actually a ketone. So this spectrum corresponds to a ketone. This one should be an easy one. We have a broad peak in addition to this peak at around 1700 or 1800. So this is a carboxylic acid. Let's look at this spectrum now. Starting with a 1500, there is almost nothing in this region. This doesn't mean anything. There is no triple bond in this region here. At 3000, if I draw this line, the only thing which I can see is this single peak here. This is definitely not an alcohol, not a carboxylic acid. So the only thing which can give a short or a small peak here is a secondary amine, because remember that primary amines will give two peaks. So this is a secondary amine. Let's move on to this spectrum now. So ketone is done, a carboxylic acid done, and then a secondary amine is also done. So we still have an alcohol and a primary amine. Again, in the 1500 region, there is a peak here. So we may have a carbonyl, a group or a double bond, depending on the structure. But for now, definitely, since the only ones which are left are alcohol and primary amine, I would say that this is a primary amine because we have two peaks here. So this corresponds to a primary amine, but definitely not an alcohol. Let's keep moving. Again, starting with the 1500 here, the only peak which I can see is this one, around 1700. So this is definitely a carbonyl, so this could be a ketone again. Nothing in here much, or could be an aldehyde. And then finally, this is an alcohol, and this is because of this broad band, which appears at around 34 to 3500. So this is the alcohol. So this is how we read the IR spectrum. We will have one more example, and now we will get into more details about the structure. So again, you are given this spectrum from the same book, and you are asked to identify which structure is the correct one. So let's follow the methodology that we used before. Drawing this line at 1500, I can see those two peaks. This corresponds definitely to a double bond, so we have a double bond in our compound, carbon-carbon double bond, and also this peak with high intensity, which corresponds to a carbon-oxygen bond. If I draw this line at 3000, I can see that there is a short peak here, which is telling me that there is a hydrogen at a double bond. So this is all the information which I can get from the IR spectrum. Now let's look at the structures. So our compound should have a double bond O and should have a double bond. This one doesn't have a double bond O, so out. This one doesn't have a double bond. It has a double bond O, but it doesn't have a double bond, so also out. This one doesn't have a double bond O, out. Again, out, out. There are no alkyne peaks, so there's no alkyne. There's no alkyne here, so also out. So the only one which are left are basically this one and this one. Both of them have carbonyls, and both of them have a double bond with a hydrogen. How can I differentiate between these two? The main difference between those two is that this one is conjugated, whereas this one is not conjugated. Remember that from the previous video, I mentioned that if the bond is conjugated, so if there is no resonance, so instead of the carbonyl peak being appearing at 750 or 750, it will go down a little bit, let's say to 1680 or to 1650. So let's look at the spectrum which we have here, and we can see that the carbonyl peak is around 1720, which is telling us that there is no conjugation. So our compound is not conjugated, which means that our compound actually will be this one and not this one, because this one is conjugated, so its peak usually will occur at around 1650. So this is the right structure of the compound. Let's try to practice more. And in this question here, again, we have to match the structures with the different spectra. Starting with the first one. Around 1500, this is a 1500. I can see that there is a short peak here. So definitely this is a carbon-carbon double bond. And just to make sure, let's look, there is nothing here in this region, so there is no triple bond. This is 3000. Again, small peak at around 3100 confirms that we have a double bond with a hydrogen on it. And the only structure which has a double bond is this one. So this is the first compound, and it corresponds to this spectra. Let's take a look at the second one now. This one here, again, drawing a line at 1500. The only thing which I can see is a sharp or high intensity peak around 17, but around 1750. This is consistent with a carbon double bond, also with a carbonyl. Now we have carbonyl here and we have carbonyl here. But again, this is a carboxylic acid, so there should be a brown band here, which is not there, which means that this compound is actually this. Let's move to this spectrum, 1500. There is nothing here, so no double bonds, no triple bonds, nothing. The only thing which I can see is even after, so after 3000 there's nothing, there's just this peak. So most probably this compound is an alkane. It's not an alkyne, it's not an alkene, it's not a carbonyl, it doesn't have anything, and most probably this is the structure of the compound. This should be an easy one because we have this broad band which is telling us that there's an alcohol in our compound, and so this is the spectrum of this alcohol. Again here, this is a very broad peak which is telling us that this is a carboxylic acid, and here this is a 1500. So we have few peaks here. This could be a double bond, but again, this is not none of the, because this is now all of these have been identified. So actually the only one which is left is NH2, and let's see if this is consistent with the primary amine. And yes, we do have those two peaks which are consistent with those with the NH2. So this is probably a primary amine. This region, we're not sure, maybe there's a double bond, maybe this is not the correct structure, but anyways, for now, this is the only spectrum which corresponds or which matches with this compound. So this is most probably the spectrum of a primary amine. So this is basically how can we read IR spectra and identify the different functional groups or different compounds using the IR spectra.